All right, so get this.
Hmm.
We're diving into a world where thoughts can control machines
Wow.
and robots can move like humans.
Yeah.
We're taking a deep dive into Neuralink's brain-computer interface and Tesla's Optimus robot.
Okay.
Unpacking this video breakdown,
Right.
it has me seriously questioning what the future holds.
Yeah.
Get ready, because this is some serious science fiction stuff.
It's pretty wild stuff.
Yeah.
What's really capturing everyone's attention, I think,
Mm-hmm.
is that it's not about making things a little bit better.
Right.
It's about completely changing
Yeah.
our understanding of human limitations.
Yeah. I'm totally with you on that.
Okay?
So let's start with Neuralink.
Sure.
Their N1 implant
Mm-hmm.
sounds like something a mad scientist dreamed up.
Yeah.
This tiny device that gets surgically implanted in the brain
Great.
can actually read brain signals
Oh, yeah.
and translate them into commands for machines.
It's wild.
How is that even possible?
So the N1 implant focuses on the motor cortex area of the brain, which is responsible for controlling movement.
Right.
So when you think about moving your arm,
Mm-hmm.
your neurons fire off electrical signals,
Okay.
and the N1 picks up on those signals.
Right.
Then sophisticated algorithms decode those signals
Mm-hmm.
into instructions a machine can understand.
Oh, wow.
It's like having a translator for your thoughts.
Okay.
Right.
So it's not actually like reading our minds.
No.
It's more like eavesdropping on the electrical signals our brains are already sending out.
Yeah,
It's
exactly.
pretty wild.
Yeah.
But does it actually work?
Well, Neuralink's PRIME study demonstrated that the N1 could help paralyzed individuals control digital devices,
Oh, wow.
like smartphones and computers,
Okay.
using just their thoughts.
That's incredible.
Yeah, and that's already a huge leap forward
Right.
in terms of restoring independence and communication for people with disabilities.
Absolutely.
Yeah.
So we're talking about controlling the digital world with your thoughts.
Right.
But what about the physical world? That's where Tesla's Optimus robot comes in.
You got it.
Right.
Tesla's Optimus is a humanoid robot
Okay.
designed to move and function like a human,
Right.
with a real emphasis on
Yeah.
replicating our natural biomechanics.
Right.
It's not just about looking human-like.
Mhm.
It's about understanding and replicating
Yeah.
the nuances of human movement.
So it's not just like a clunky machine.
No.
It actually moves like us.
They're trying to make it move like us.
Yeah. How do they even pull that off?
Tesla's engineers have really gone deep
Okay.
into studying human anatomy and movement patterns.
Right.
And they've applied that knowledge to Optimus's design.
Yeah.
One of the most impressive things is the level of dexterity they've achieved with Optimus's hands.
Oh, wow.
They have 22 degrees of freedom.
22 degrees of freedom.
Yeah.
What does that even mean?
That's how many different ways a joint can move.
Oh.
To put that into perspective,
Yeah.
most robotic hands only have 6 or 7 degrees of freedom.
Okay.
Human hands have 27. Wow,
So they're getting close.
that's really close.
Yeah.
Okay, so Optimus has got some
Mhm.
seriously flexible fingers,
Right.
almost like ours.
Pretty much.
What can it actually do with those hands? Is
Mhm.
it all just theoretical?
Well, in demos, they've shown it catching a tennis ball,
Wow.
which requires some pretty impressive hand-eye coordination and fine motor control.
It's insane.
Yeah.
So on one hand, we've got this mind-blowing brain implant from Neuralink,
Right.
and on the other hand, we've got this incredibly agile robot from Tesla.
Mm-hmm.
How do these two revolutionary technologies connect?
Right.
Is this where Elon Musk's vision comes in?
Absolutely.
Okay.
Elon Musk believes the N1 implant could essentially intercept those brain signals
Okay.
that are usually meant for your limbs
Right.
and redirect them to Optimus.
Okay.
So instead of your thoughts controlling your arm,
Yeah.
you'd be controlling a robotic arm.
Whoa.
Essentially,
Hold on a second.
you'd be controlling a robotic body with your mind. Are we talking about people transferring their consciousness into a robot body?
Well,
Is that even possible?
it's not conscious mistransfer in the sense of uploading your entire mind
Okay, yeah.
into a robot,
Right.
at least not with the current technology.
Mhm.
It's more about controlling the actions of a robotic body
Okay.
as if it were an extension of yourself.
That makes a little more sense.
Right.
But even just controlling a robot body with your thoughts
Yeah.
is a huge deal.
It is a huge deal.
I mean, what are the implications of this kind of technology?
Right.
We're talking about a complete paradigm shift here.
Yeah, the potential applications are vast.
Okay.
Restoring mobility for people with paralysis
Right.
is one of the most obvious and impactful possibilities.
That's amazing.
But imagine enhancing human capabilities in all sorts of industries,
Like what?
like construction, logistics, manufacturing,
Wow.
even space exploration.
Yeah.
Think of astronauts controlling robotic avatars to work in hazardous environments.
Right. Instead of risking a human life, you send a robot to
Exactly.
do those dangerous jobs.
That's right.
But wouldn't all of this be incredibly expensive?
Yeah, that's a valid concern.
Right.
And accessibility is a major consideration.
Mm-hmm.
But Tesla isn't known for.
Okay.
It's focused on scaling production
Right.
and bringing down costs.
Yeah.
Their goal is to eventually make Optimus robots as affordable as Tesla cars.
Wow.
And Neuralink is also working towards making their implants more accessible
Okay, that's reassuring to hear.
to a wider audience.
But even if the cost comes down,
Mhm.
there's still the technical challenge
Yeah.
of making this technology work seamlessly, right? I
Yeah.
mean, controlling a robotic body is
Yeah.
a lot more complex than controlling a smartphone,
Absolutely.
right?
Translating the nuances of human movement
Mm-hmm.
into precise robotic actions
Yeah.
is incredibly complex.
Right.
For example,
Okay.
think about picking up a delicate object.
Yeah.
Humans do this intuitively, adjusting our grip strength and finger movements based on subtle feedback from our senses.
Right.
Replicating that level of sensitivity and responsiveness in a robot
Right.
is a huge challenge.
That's a great point.
Yeah,
We take our natural movements for granted,
right.
but for a robot, it's all about algorithms and sensors trying to mimic those movements.
Exactly.
It makes you really appreciate
Yeah,
how amazing the human body is.
exactly.
Yeah.
And that's what makes this whole endeavor so fascinating.
Right.
We're trying to replicate something
Mm-hmm.
that we ourselves don't fully understand.
Right.
The complexity of human movement and cognition.
It's pretty wild.
Pushing the boundaries of engineering neuroscience.
Yeah.
Artificial intelligence all at once.
And it's raising some pretty big questions about what it means to be human.
Right.
Right.
Yeah.
If we can control robotic bodies with our minds,
Mm-hmm.
does that change our definition of humanity?
That's a good question.
What about the ethical implications?
Those are questions that philosophers and ethicists are grappling with right now.
Yeah.
There are no easy answers.
Yeah.
As we continue to blur the lines
Yeah.
between human and machine,
Mm-hmm.
we need to be having those conversations
Right.
about where we draw the line,
Absolutely.
what our values are,
Mm-hmm.
what kind of future we want to create.
Absolutely.
Yeah.
But before we dive into those philosophical depths,
Okay.
I want to go back to Neuralink for a minute.
Sure.
You mentioned that they're focused on restoring mobility,
Mm-hmm.
but I heard they're also working on a project to restore vision for the blind.
Yes.
Is that right?
Their Blind Sight project
Okay.
recently received breakthrough device designation from the FDA,
Wow.
which is a big deal.
Yeah.
It involves implanting a device that can stimulate neurons in the visual cortex,
Okay.
essentially creating a visual image in the brain.
That's mind-blowing.
Yeah.
So we're not just talking about restoring movement.
Right?
We're talking about restoring senses as well. It's like science fiction is becoming reality right before our eyes.
It really is.
Neuralink is pushing the boundaries of what we thought was possible in terms of human augmentation and sensory perception.
Yeah.
It's a really exciting time to be alive.
It is an exciting time.
This is already so much to process. And
Right.
I can only imagine what else we're going to uncover as we go deeper
Right.
into this world of Neuralink and Tesla Optimus.
Yeah. And it's not just about, like, restoring lost abilities.
Right.
It's about potentially, like, augmenting human capability
Right.
beyond what we currently consider possible.
Yeah, that's where it gets really interesting.
Right.
Where do we draw the line between therapy and enhancement?
That's a great question.
But before we go down that rabbit hole,
Yeah.
I want to get back to Optimus for a minute.
Sure.
We talked about its dexterity and human-like movement.
Right.
But what about its practical applications?
Yeah.
What can this robot actually do in the real world?
One of the things that makes Optimus so compelling is that Tesla is approaching it
Mm-hmm.
with a platform mindset,
Okay.
meaning they're designing it to be adaptable and upgradable,
Okay.
much like a smartphone.
So it's not just a one-off robot.
Right.
It's designed to evolve and improve over time.
Exactly.
Kind of like how our phones get software updates and new features.
Exactly.
Oh, cool.
Yeah, Tesla envisions Optimus
Mm-hmm.
becoming an integral part of various sectors,
Like what?
from healthcare and logistics to manufacturing and even space exploration.
Okay, let's break those down a bit.
Okay.
How could Optimus be used in healthcare, for example?
So imagine Optimus assisting nurses with patient care,
Okay.
lifting and moving patients,
Hmm.
or even performing delicate surgical tasks
Wow.
under the guidance of a surgeon.
Okay.
Its strength, precision,
Mm.
and tireless nature could be invaluable in a hospital setting.
That would be a game changer for nurses who are often overworked and understaffed.
Right.
It could free them up to focus on the more human aspects of care, while the robot handles the heavy lifting, literally.
Literally, yeah.
And in logistics, Optimus could revolutionize warehouse operations,
Right.
handling heavy lifting, sorting packages, and even making deliveries.
Mm-hmm.
Its ability to navigate complex environments
Yeah.
and manipulate objects with dexterity
Right.
makes it well suited for these tasks.
Absolutely.
It would definitely be more efficient than having humans do those repetitive tasks.
Yes.
And it could work around the clock without getting tired or needing breaks.
Mm-hmm.
Plus, it could handle hazardous materials without putting human workers at risk.
Exactly.
And speaking of hazardous environments,
yeah.
Optimus could also play a crucial role in disaster relief efforts,
Yes.
search and rescue missions, or even exploring other planets.
Yeah, think about it.
So robots could be the pioneers,
Yeah.
paving the way for human settlements on Mars or beyond.
It's a crazy thought.
That's a pretty wild thought.
Yeah.
And because Optimus is designed to be so human-like in its movements and dexterity, it could perform tasks that would be difficult or impossible for traditional robots.
Yeah.
Like operating machinery designed for humans.
Right.
Or navigating tight spaces.
Yes.
This is all incredibly exciting,
Yeah.
but I can't help but wonder about the potential downsides.
Sure.
Earlier, you mentioned accessibility and the potential for inequality.
Yes.
Could you elaborate on that?
Of course.
Okay.
If this technology remains expensive,
Right.
it could exacerbate existing inequalities.
Yeah.
Imagine a world where only the wealthy have access to robotic assistants,
Yeah.
advanced prosthetics,
Mhm.
or enhanced abilities.
That would create like a two-tiered society
Exactly.
with a significant divide between the haves and the have-nots.
That's right.
That's a dystopian scenario we definitely want to avoid.
Absolutely.
It's crucial that we think about equitable access to these technologies from the very beginning.
From the very beginning.
Yeah.
Absolutely.
And even if we address the issue of access, there are still ethical questions surrounding human identity and augmentation.
Yeah. What does it mean to be human?
Right.
If someone is controlling a robotic body with their mind,
Yeah.
does that make them less human?
What happens to our sense of self
Right.
and our relationship with our bodies
Yeah.
when technology becomes so deeply integrated?
Those are profound questions.
They are.
And I don't think there are easy answers.
It seems like we're entering uncharted territory,
Absolutely.
where the lines between human and machine become increasingly blurred.
We are.
Yeah,
And that's why it's so crucial to have these conversations now.
right.
While these technologies are still in development,
Yeah.
we need to think critically about the potential consequences, both positive and negative,
Absolutely.
and make sure we're shaping a future
Right.
that benefits all of humanity.
You're right.
Yeah.
We need to approach this with both enthusiasm and caution.
I agree.
But before we get too lost in the philosophical weeds, I want to go back to the Convoy study for a minute.
Sure.
It's focused on restoring movement for people with paralysis, right?
Yeah.
Can you tell me more about how that actually works?
The Convoy study is testing the ability of the N1 implant
Okay.
to control assistive robotic limbs.
Okay.
Essentially, the implant picks up on the brain signals
Right.
that are intended for the person's own limbs, but those signals are then redirected to a robotic limb instead.
So it's like rewiring the brain
Yeah.
to control a new set of limbs.
Right.
But in this case, those limbs are robotic.
Exactly.
That's incredible.
It is incredible.
Have they had any success with this yet?
Yes.
Yeah.
There have been some remarkable stories coming out of the Convoy study.
Like what?
One participant, a young man named Nolan Arbo,
Okay.
who became quadriplegic after an accident,
Oh,
was able to play chess and video games
wow.
using just his thoughts to control a robotic arm.
That's amazing.
It is amazing.
Must be an incredibly empowering experience for him.
I can't even imagine.
To regain that level of control over his environment,
Yeah.
it must feel like anything is possible.
Exactly. And that's what makes this technology so potentially transformative.
Right.
It's not just about restoring function. It's about restoring hope and possibility.
It really makes you think about the incredible resilience of the human spirit
Yes.
and the power of technology to amplify that resilience.
Yeah.
But I'm also curious about the challenges of translating thought into action.
Sure.
Is it as simple as thinking, move arm,
No.
and the robot arm moves?
No, it's definitely more complex than that.
Okay.
The brain doesn't work in simple commands.
Right.
It's a vast network of neurons firing in complex patterns.
So how does the N1 implant actually decode those patterns and
Ah.
translate them into precise movements?
That's where machine learning comes in.
Okay.
The N1 implant is constantly learning
Mm-hmm.
and adapting to the individual's unique brain patterns.
So it's like a personalized translator
Yeah.
that gets better over time?
Exactly.
As it learns the nuances of the individual's brain activity.
It does.
That's
But it
incredible.
highlights the fact that this technology is not a one-size-fits-all solution.
Right.
It requires a high degree of personalization
Yeah.
and ongoing calibration to work effectively.
That makes sense. Every brain is unique.
Right.
So it would stand to reason that the technology needs to be tailored to the individual.
That's right.
But I imagine there are also challenges in terms of the robotic limbs themselves.
Yes, absolutely.
Right.
The design and engineering of the robotic limbs
Yeah.
is just as crucial as the brain-computer interface itself.
So we're talking about a convergence of cutting-edge technologies here.
We are.
Advanced robotics, artificial intelligence materials, science, and neuroscience, all coming together to create something truly revolutionary.
Precisely.
And it's the synergy between these different fields
Right.
that's driving this rapid pace of innovation.
It's amazing.
It's mind-boggling to think about all the different disciplines
I know.
involved in making this happen.
Yeah.
But it's also inspiring to see what's possible
Yeah.
when brilliant minds from different fields come together to solve a problem.
It's a testament to the power of human ingenuity and collaboration.
That's a great point.
Yeah.
It gives me hope for the future.
Me too.
But speaking of the future, where do we go from here?
Well, as the Convoy study continues,
Yeah.
we're going to learn a lot more
Mm-hmm.
about the potential and limitations of controlling robotic limbs with thought.
And I imagine as the technology improves,
Yeah.
the applications will expand beyond just restoring mobility. We could see robotic limbs that are stronger, faster, or more dexterous than human limbs.
Exactly. And that raises all sorts of fascinating questions
Right.
about the future of human capabilities.
Will we eventually see a merging of human and machine
Right.
where technology enhances our physical and cognitive abilities
Yeah.
to superhuman levels?
It's a big question.
That's a question for the philosophers and the futurists. But it's definitely something to ponder
It is.
as we continue this deep dive into the world of Neuralink and Tesla Optimus. Okay, so we've covered a lot of ground here.
We have.
From the intricacies of the N1 implant to the impressive capabilities of Optimus.
Right.
But before we wrap up, I'd love to take a step back.
Okay.
We're going to try to connect all the dots.
Yeah, that's a good idea.
So let's recap.
Okay.
We started with Neuralink's groundbreaking N1 implant,
All right.
a device capable of turning thoughts into actions,
Yeah.
first in the digital world,
Mm-hmm.
and now with the Convoy study in the realm of physical movement.
It's credible.
And we explored the remarkable capabilities of Tesla's Optimus,
Yeah.
a humanoid robot designed to mimic human biomechanics,
Right.
with its incredibly dexterous hands
Mm-hmm.
and a platform built for continuous evolution.
That's right.
And we touched upon the mind-boggling potential of these technologies working together,
Yeah.
restoring mobility,
Yeah.
enhancing human capabilities,
Right.
and maybe even fundamentally changing our understanding of what it means to be human.
Absolutely.
We also discussed the crucial ethical and societal considerations
Score.
that come with such advancements, like
Yes.
the potential for inequality and the philosophical questions surrounding human identity and augmentation.
We have to consider all of that.
Right, because with any revolutionary technology,
Mm-hmm.
there's always a risk of unintended consequences.
Yeah.
We need to be mindful of those risks
Absolutely.
while also embracing the incredible potential of these innovations.
I agree.
So as we wrap up this deep dive,
Yeah.
I want to leave our listeners with something to ponder.
All right.
If you could control a robotic body with your thoughts,
Mm-hmm.
what would you do with it?
Wow.
What limitations would you overcome?
That's a great question.
What new possibilities would you explore?
It really makes you think.
It's a future filled with both promise and uncertainty.
It is.
But one thing is for sure,
Okay.
it's going to be an incredible journey.
I'm excited to see what happens.
Thanks for joining us on this deep dive into the world of Neuralink and Tesla Optimus.
It's been a pleasure.
Until next time, keep exploring and keep questioning.